We walk on it, we build with it. But how often do we think about sand? This humble material, born from eroded mountains and ground down by the relentless ocean, is the very foundation of glass. Yes, glass, that seemingly magical substance, starts its journey as simple sand, specifically silica sand or quartz. But sand alone doesn't make glass, it needs help. Enter soda ash, lowering the melting point of the sand and making it workable. Then comes limestone, lending durability to the mix, ensuring the glass can withstand time's relentless march. And finally, a pinch of magic cullet, recycled glass from past lives, added to improve efficiency and reduce waste. These four ingredients, each playing a crucial role, form the genesis of glass. The journey from these raw materials to the sparkling windows, delicate vases, and powerful telescopes we see around us is a testament to human ingenuity. It's a story of harnessing Earth's elements and transforming them into something extraordinary. Imagine a fiery inferno, a crucible where temperatures soar to unimaginable heights, reaching over 2,500 degrees Fahrenheit. This is the heart of glassmaking, the furnace where the transformation begins. Here, the carefully measured ingredients, sand, soda ash, limestone, and cullet, melt together, their individual identities dissolving into a molten mixture. This molten mix, glowing with an ethereal light, is then carefully guided through a series of steps, each one shaping its destiny. First, it undergoes fining, where bubbles are meticulously removed, leaving the glass crystal clear. Next comes the crucial forming stage. Here, the molten glass, pliable and yielding, is molded into its final form. The methods are as diverse as the glass itself, blowing, pressing, drawing, each technique giving birth to a different form. Finally, the glass, still hot from its fiery birth, is slowly cooled in a process called annealing. This prevents cracking and strengthens the material, preparing it for its journey into the world. When we think of glass, our minds often go to windows, those transparent portals connecting us to the outside world. But the world of glass is far more diverse than that. It's a spectrum of compositions, each tailored for specific purposes. Take flat glass, the most common type, used for windows, mirrors, and countless other applications. It's transparent, allowing light to pass through, connecting us visually to our surroundings. Then there's fiberglass, a marvel of engineering where glass fibers are woven together, creating a material that's strong, lightweight, and surprisingly insulating. And let's not forget optical glass, the foundation of our lenses, telescopes, and microscopes. This meticulously crafted glass with its precise refractive properties allows us to see the world in entirely new ways, from the vastness of space to the intricacies of a cell. Glass, despite its apparent fragility, possesses a unique set of properties that make it a material of extraordinary versatility. It's an enigma, existing in a state between a solid and a liquid, its molecules locked in an amorphous structure. This unique nature gives glass its remarkable combination of transparency, hardness, and chemical resistance. Consider its elasticity. Glass can bend and flex under pressure, returning to its original shape when the stress is removed. Think of a thin glass window pane vibrating in the wind. This elasticity contributes to its durability, allowing it to withstand minor impacts without shattering. Then there's its thermal and electrical insulation. Glass is a poor conductor of heat and electricity, making it ideal for applications where these properties are crucial. From the windows in our homes to the delicate filaments in light bulbs, glass protects us and facilitates our modern lives. Section 5. The breaking point. Understanding glass's limits. While glass possesses remarkable strength and resilience, it's not invincible. It has its limits, its breaking point. This inherent vulnerability arises from its unique atomic structure, the amorphous arrangement of its molecules. Unlike metals, which can deform plastically under stress, glass responds differently. Microscopic flaws, often invisible to the naked eye, can act as stress concentrators, weakening the material. These flaws, created during the manufacturing process or through everyday wear and tear, can propagate under pressure, leading to sudden and often dramatic fractures. Understanding these limitations is crucial in designing with glass. Factors like glass thickness, shape, and even the surrounding environment play a role in its overall strength and durability. But even with these limitations, glass remains a remarkable material, its beauty and versatility continuing to inspire and amaze. Section 6. Measuring the invisible hardness and density. We can see the transparency of glass, feel its smoothness, but what about its hidden properties? How do we measure the invisible forces that govern its behavior, its hardness and density? Scientists have developed ingenious methods to quantify these characteristics, allowing us to better understand and utilize this fascinating material. Hardness, a measure of a material's resistance to scratching, is crucial in determining its durability and suitability for various applications. The Mohs hardness scale, a relative scale ranging from 1, softest, to 10, hardest, places glass around 5.5, similar to a steel knife blade. This means glass can scratch materials with a lower hardness, but will be scratched by materials with a higher hardness, such as diamond. Density, on the other hand, measures how much mass is packed into a given volume. Glass with its tightly packed atomic structure has a relatively high density, typically around 2.5 grams per cubic centimeter. This density contributes to its weight and its ability to refract light, giving it that characteristic sparkle. Section 7. Glass, a reflection of our ingenuity. From the crude glass beads of ancient civilizations to the high-tech fiber optic cables that power our modern world, glass has been a constant companion on humanity's journey of innovation. It's a testament to our ingenuity. It's a reflection of our desire to shape and mold the world around us. The story of glass is inextricably intertwined with the story of human progress. Early civilizations, captivated by its beauty and versatility, used it for ornamentation, creating beads, jewelry, and decorative vessels. As our understanding of glassmaking evolved, so did its applications. The invention of glassblowing, a revolutionary technique that emerged around the 1st century BC, marked a turning point. Suddenly, glass could be shaped into countless forms, leading to the creation of bottles, jars, and even window panes. This innovation transformed daily life, making glass an indispensable part of human civilization. Section 8. The future through a glass lens. As we stand on the cusp of a new era, an era defined by technological advancements and a growing awareness of our planet's finite resources, glass continues to play a pivotal role in shaping our future. Its versatility, sustainability, and unique properties make it an ideal material for addressing some of the world's most pressing challenges. In the realm of renewable energy, glass is playing a critical role in capturing and harnessing the power of the sun. Solar panels covered in tempered glass silently convert sunlight into electricity, providing clean energy for homes and businesses. The transparency and durability of glass make it an ideal material for this application. Beyond energy, glass is finding new applications in medicine, communication, and even art. Biocompatible glasses are being developed for bone implants and tissue regeneration, offering hope for patients with debilitating conditions. Fiber optic cables, those strands of glass thinner than a human hair, transmit vast amounts of data at the speed of light, connecting us globally and fueling the digital revolution. Section 9. A universe of glass, keep exploring. The journey of glass, from the sands of time to the cutting edge of technology, is a testament to the power of human curiosity and ingenuity. It's a story that continues to unfold, with each new discovery and innovation revealing more about this remarkable material. As we've explored the origins, properties, and applications of glass, we've only scratched the surface of this fascinating subject. There's a universe of knowledge waiting to be discovered within the heart of glass. So the next time you hold a glass object, take a moment to appreciate its journey, its complexity, and its enduring legacy. Let it spark your curiosity, ask questions, delve deeper into its mysteries. For within the heart of glass lies a reflection of our own creativity, a testament to our ability to harness the Earth's resources and transform them into something extraordinary. Keep exploring the universe of glass, and who knows what wonders you might uncover.